Step onto the pad. White light climbs the walls. Behind you, a machine starts reading your body. Every atom, every electron, every spin. And then it deletes them. Not a copy of you, you. 3,000 miles away, something opens its eyes and remembers your childhood. That's the part the movies leave out. Here's what's strange. Teleportation isn't fiction. It happened in a lab in Innsbruck in 1997. It's happened thousands of times since. Photons, trapped ions, electrons locked inside diamond. In 2017, a Chinese satellite called Messius teleported a quantum state from the ground into orbit, over 1,400 kilometers. The word in those papers is literally teleportation. So the real question was never whether it's possible. It's what it would cost and what would arrive. Because buried in the math, there's one detail nobody on the Enterprise ever mentions. The machine doesn't move you. It can't move you. What it does instead is worse. We'll get to that. First, a number. To rebuild you somewhere else, you need your blueprint. Not roughly, exactly. Every atom in the right place, at the right energy, in the right relationship with its neighbors. There are around 7 octillion atoms in an adult human body. 7 followed by 27 zeros. A group of physics students at the University of Leicester tried to put a file size on that. Their estimate landed around 10 to the power of 42 bits. Then they asked how long it would take to transmit at a fast connection speed. The answer came back in years, then in millions of years, then it kept climbing. Their final figure was longer than the age of the universe, multiplied by hundreds of thousands. So the bottleneck isn't the beam, it's the upload, which means a real teleporter needs a trick, a way to move information without ever reading it. And that's convenient, because the universe doesn't let you read it anyway. Werner Heisenberg, 1927. You cannot know a particle's exact position and its exact momentum at the same time. Not because our instruments are clumsy, because there is no hidden answer sitting there waiting to be found. Look closely enough, and the thing you're looking at changes under the lens. So a perfect scan requires the one thing physics refuses to permit. Star Trek noticed this problem. Their fix was a made-up box in the script called the Heisenberg compensator. When a magazine asked the show's technical advisor how it worked, he said, "It works very well, thank you." That was a joke. 6 years earlier, a team of physicists had already found the real one. And it works by refusing to look. Charles Bennett and 5 colleagues published the paper that starts all of this. Here's the idea. Take 2 particles and entangle them. Link them so tightly they stop being 2 things and become one system with 2 ends. Ship one end to the destination, keep the other. Now bring in the thing you want to teleport. Don't measure it. Measure it against your half of the pair. What comes out is noise, random numbers. It tells you nothing about the original. But send those random numbers to the far end by ordinary radio, and the receiver can use them to turn their particle into your original. Perfectly, down to the last quantum detail. The state moved. No particle crossed the gap. Nobody ever read it. Sounds like a clean win. It isn't. Because that measurement, the one that produced pure noise, did something to the original. Something permanent. There's a rule in quantum mechanics called the no-cloning theorem. You cannot make an identical copy of an unknown quantum state. Not ever. Not with better hardware. Not with more money. The universe permits exactly one of you at a time. So when a teleporter assembles a perfect you at the far end, the math demands payment. The original has to stop existing. Not as a safety feature. Not as a design choice. As a conservation law. Every teleportation experiment ever run has destroyed the original at the exact instant the new one appeared. Every single one. The machine isn't a door. It's a trade, which leaves a question you may not want answered. If the thing at the far end has your memories, your scars, your handwriting, your fear of the dark, is that you? Or is it just extremely well informed about you? Hold on to that, because we still haven't built a body. Information doesn't have shoulders, so here's the surprise. You don't need your atoms. There is no serial number on a carbon atom. 2 atoms of the same element aren't merely similar, they're formally indistinguishable. Swap them, and the universe cannot tell. The receiver doesn't need anything of yours. It needs a tank of raw material and the pattern. That's the good news. It's also the most disturbing line in this script, because it means you are not your matter. You are an arrangement, and arrangements are expensive. Materialize a body from pure energy, and you're spending about 6 billion joules, roughly 4 days of every power plant on Earth, per passenger. Now, back to that question. Because a philosopher got there before the physicists did. Parfit, 1984. He imagines the Mars teleporter, and then he imagines it malfunctioning. The scanner runs, the copy wakes up on Mars, perfect. But the original on Earth doesn't die. It just gets a diagnosis, cardiac damage, a few days left. So now there are two. They speak to each other over a video link. Both remember stepping onto the pad. Both are completely certain they're the real one. Parfit's conclusion was that which one is really me has no answer because it was never a real question. Identity isn't cargo. Nothing gets transported. It's a story about continuity that your brain tells minute to minute. And it's convincing only because nothing has ever interrupted it. Here's the twist. That nightmare can't happen. No cloning forbids it. Two of you is not a malfunction the universe allows. Physics agrees with the philosopher and closes the door by force. So could you actually build one? Maybe. And maybe far sooner than those numbers suggest. Because here's the loophole nobody expects. Your brain is warm, wet, and loud. 310 Kelvin. Everything in there is vibrating. Quantum states inside a skull survive for a vanishingly small fraction of a second. Thoughts take milliseconds. Your mind almost certainly doesn't run on quantum detail, which means a teleporter may not need quantum precision at all. It needs molecular precision. Still absurd, but absurd is an engineering problem. Forbidden is not. And there's one more design. The one that doesn't look like a teleporter at all. Replace one cell, then the next, then the next. Slowly enough that you stay conscious the entire way through, and there is never a moment where nothing exists. No gap, no copy, no trade, which should feel reassuring, except your body is already doing it. The material you're made of turns over constantly. The atoms carrying your thoughts right now were somewhere else a few years ago, and they'll be somewhere else again. You have already been rebuilt, repeatedly. You just weren't awake for the handover. So yes, you could probably build a working teleporter. And on the day you step onto that pad, it will do exactly what it was engineered to do. It will read you perfectly. It will destroy you completely. And it will hand the far end something that walks off smiling, certain that nothing happened. You will never find out if it's right. Nobody who steps in ever does.